Very good morning, everyone, for second day of best practices meet that we are conducting virtual this year. We had amazing day yesterday. We discussed quite more themes and different topics, and we got good response from you. We are hoping to get same response today as well. This morning we are meeting to have this workshop in partnership with Target India. So we are having workshop theme for today is demystifying intel-driven and detection-oriented incident response. Uh, so, uh, as you know that no conference, no security conference is complete without talking about threat intelligence, importance of threat intelligence for security operations centers, and how we can quickly detect any of the malicious event, any of that unlawful event, and create a good response to that particular event. So very relevant topic to start our morning. So to discuss this particular theme, I have a very eminent panelist and speaker from a target in India. So I would like to call my speakers for the workshop one by one. So firstly, I'm having Bhupesh Gupta, who is a director cybersecurity for Target in India. So I would like to welcome Bhupesh on the stage. Welcome, Bhupesh. Secondly, I am having a second speaker with me, who is Chandan Vatsa, who is a lead engineer for Target in India, who will be also speaking on some of those importance and key aspect of Intel and detection-driven incident response. Welcome, Chandan. Hi. As we discussed, right, that no conferences are complete without taking the discussions on a threat intelligence, right? Because we have been seeing activities last year as well as this year. There are big ticket breaches and hacks, including the SolarWinds hack, or maybe talk about the recent the KCA supply chain attack, or maybe other attacks on the key airlines and other critical information infrastructure such as a Colonial Pipeline. So what's the takeaway that we have been taking from those key incidents which are happening in the last 1 or 2 years? That detection is the key, because if you see some of the attack which are happening, those are getting detected after some time, so that your detection is not happening on the time, so you have a very less time to respond to those particular incident, unless it makes a severe impact to your organization or your peer organization. Take an example of a solar wind. It has all the malicious events and backdoor implementation started in September 2019, and we detected that attack in the December 2020. So it's almost 1 year and 4 months of the time period. So key here is that threat intel can be a core component of your security operations, which can help you to detect those attacks quickly, and help you to frame your response matrix such a way that you'll be able to respond quickly, and possibility that you recover from those incidents is really faster and quicker. So I think that is the key aspect of it. While we're talking about the detection of any event, it is also important that what kind of intelligence that you receive. Now we talk about the intelligence is a core of security operations, but it also matters that you receive a right intelligence, right? You receive the complete intelligence, because we talk, right, the misinformation or maybe wrong intelligence is as good as the no intelligence. So once you have the intelligence, it has to be complete, it has to be accurate, it has to be relevant to your organization, and it has to be a timely, it has to be a time sensitive, it has to be a right intelligence on right time. So I think based on the CART rule, we need to have the intelligence very appropriate, and I think that is where we are going to discuss today. That what is the importance of having intelligence right, appropriate, and relevant to your organization, so that you will be able to better detect it and respond to any of the event. So I think that is all about the theme and the context for today's workshop. And without a further delay, I would like to hand over to Bhupesh, who have a very nice presentation and framework about threat intelligence, which will definitely help you to streamline processes in your security operations center. So over to Bhupesh and Chandan. Looking forward to your insights. And one thing before I hand over to Bhupesh, that we wanted to make this workshop more interactive. So guys, please ask questions. Whatever questions you have, please put it into the Q&A section or a chat section. I will try to take those questions one by one during the workshop. Over to you, Bhupesh. Thank you so much.
Excellent, Vivek. Thanks for the nice introduction and setting up the context for today's talk. Thanks everyone for joining in today. I will introduce myself one more time. My name is Bhupesh Gupta. I'm Director for Cybersecurity in Target. Um, in as a director, I have been responsible in Target for managing cybersecurity teams, including incident response, detection engineering, intelligence, and product security. I have about 15 years of experience in cybersecurity, and in my tenure, I have been engaged in building security operations centers and cyber fusion centers from ground up. And that's the same case with Target India here. And one more thing about me is I've been a speaker to in DSCI before as well. I have done a masterclass earlier as well on DevSecOps, and I'm very passionate about diversity and inclusion. Target has been very conscious about diversity and inclusion, and you have seen in some of the conversation and talks in this BPM also. So that was about me. Thanks for giving this opportunity, DSAI, for us to talk about cybersecurity best practices. As Vivek said, it is important to understand and share information, right? Because today the threat actors are um, they are advanced, they are sophisticated, and to keep pace with the threat actors, we need to share information. We need to share those best practices, and this is why we are here today. I will give it to Chandan to introduce himself, and then I will take over. Chandan, over to you.
Yeah, thank you, Krish. I think Vivek has very well summarized the overall context and all. I just want to add one point into it. Like we say that we can't stop adversaries from doing the attacks, right? One thing we can do is we can just detect. As soon as you can detect it in your environment, and that's it, right? You can contain them. About me, so my whole career, like I can divide it into two parts. First is the technology, and then from last 10 years, I'm working in the cybersecurity domain. From last 2 years, I'm in current role, and I'm passionate about writing the detection and creating cybersecurity tools for detection and all. So that's about it. Back to you, Mukesh.
Excellent. Thank you, Chandan. Let me give me a few seconds. Just I will just pop up the presentation on screen. Just 1 minute. Right. Uh, just to check, Chandan, are you able to see my screen?
Yes, I'm able to see your screen. Correct.
And is it in slideshow mode?
Yeah.
All right. Excellent. All right. So thanks again. Thanks for joining in. Today our topic is demystifying intelligence-driven and detection-oriented incident response. So this is our introduction again. I would say what can you expect in the next 90 minutes, right? So you will learn about Target's cybersecurity program, including how we leverage intelligence for our detection and incident response team. So that's the theme. So how do we connect on intelligence? We will talk about some industry challenges related to intelligence sharing between cyber teams and how Target in-house developed framework has helped us overcome those challenges. Now I'm talking about here framework, right? And uh, we will discuss this Target developed framework for threat actor verification and evaluation at length and with a demonstration towards the end. So hang tight till the end. There is a demonstration at the end as well. Uh, we hope that this class will help you solve some challenges in your own cybersecurity program. And since it is an interactive session, we would like to, we'd love to hear from your cyber defense practices, which can help us to improve our cybersecurity program. So without a further ado, I will dive in. So, this is a very interesting slide, and I would like to start because I want to set the context and the flow for the entire presentation. So I would like to start this talk with industry transformation of security operations centers that we have seen in the last few years. We have seen that cyber defense has moved from traditional security operations center, which was like primarily focused on only detection and response. And if you have been part of this transformation journey, you would have noticed and you have faced issue like heavy volume of security information events or information overload, right? Your security operations center analysts are complaining every day. There are too many events on the dashboard. What to look, how to prioritize. These were the issues at that time. And when we move to the new format or new setup of the security operations center, we call it advanced SOC, or a new terminology that came in is Cyber Fusion Center. Um, so in this new setup, more capabilities such as threat intelligence, threat hunting, detection engineering specifically, which is focused on intelligence-driven detection, and the red team, of course, because you need to test your processes, tool, and people that were added. And this new setup has been much more integrated, collaborative, and agile. And that's the need of the hour because you need to be agile to respond to the sophisticated threat actors. We talk about APT. If you see, look at today how the landscape for specifically ransomware is moving, or if you talk about any malware as a service or any ransomware as a service, you need to be agile to respond to those security incidents. So, as a company target, we have also started our journey of this transformation a few years back, and we have transformed. So today, I'm going to move to next slide, and I'm going to give you a little bit of view about before we dive into frameworks and best practices, a little bit of view of how Target Cyber Fusion Center looks like today. So I'm going to move to the next slide. So this is how Target is set up today when it comes to Cyber Fusion Center. So there are two facilities. What you see in the left is the Cyber Fusion Center in India, which is in Bangalore, and the on the right hand side is the Cyber Fusion Center in Minneapolis, USA. Our headquarters, the main headquarters in USA, and one is in India. This is how we run our 24/7 operation in Cyber Fusion Center. And when I'm talking about detection or incident response team. Uh, how we do it, we use all the state of art technology in terms of detection and incident response, and of course collaboration, because collaboration is an important key when you have a team sitting in different geographical locations, right? So how do you collaborate? That's very important, and we have state of art technology to collaborate. The next point is target-centric detection. So we will be talking about a lot this term in this whole presentation, that what it means for relevance, right? Um, so when I say target-centric detection, we only focus on what is relevant to target. When we study our threat landscape, what are the threats that matters to us and where we want to create detection. And lastly, continuous improvement. While we build these practices, we build this framework, we are not measuring it, you will not see actual success in your cybersecurity program. So we have metrics which we evaluate, measure to see our continuous improvement. Now, a few more things about target cybersecurity program is there are three major pillars, including cyber solutions, cyber risk, and cyber defense. Our focus will be on cyber defense more in this presentation. So cyber solution is all about identity and access management, digital security, infrastructure security, When it comes to cyber risk, we are talking about policy, risk compliance, assurances, and vendor security, information security office. And when it comes to cyber defense, you will see here that we have cyber development and detection. So we are very focused on building our in-house tools for detection engineering. And then we have fraud detection and intelligence and incident response. So this is how the entire target security, cyber security program is set up today. I will move on now. In this slide, you may notice that I have named this slide Blue Team Triad. And the Blue Team Triad is because this is a combination of all cyber defense teams. So if you start with CSIR, detection engineering, and cyber threat intelligence, these teams needs to work very closely to respond to threats faster, and that's the need of the hour. And I'm going to talk about it, some of the challenges that in my experience, I have faced and the industry is facing today or have faced when these teams work together. So let's talk about those challenges first. So all of the teams, let's talk about CSIRT. CSIRT has its own incident response life cycle, starting from preparation to eradication and containment of the incident. So they receive and their job is to contain and eradicate. While detection team has a flow of they concentrate on threat hunting more and intelligence more, getting intelligence so they can write detection, which is called detection operation. And then you have your intelligence life cycle. So their job is to collect the intelligence from different sources, analyze those intelligence, and disseminate those intelligence. Now, what are those challenges? Like, so their common goal is to keep the threat actor away. That's a higher goal, right? But what are the challenges that we have seen? So when these teams have different ingestion methods, different life cycles, it is important to understand what standard format of information they should use so they can share information about that adversary behavior. I'm sure that you guys are aware that when I say adversary behavior, I'm talking about TTPs. I'm talking about how an adversary functions in an environment. So what is the standard format that the adversary follow? Or what is the language that these teams should speak so they can understand each other? And how to break those silos? These are different teams, different flows, but to work together, I will give you an example. Let's suppose if a third analyst is working on an incident and there is a discussion about a threat entity or a prevalence level or an observation of a behavior, when the detection and it connects back to the detection team, does detection engineer and the CSIRT analyst speaks the same language when they're sharing information? That is important. So to overcome that challenge, and this is there's a lot of crux to this presentation, is to overcome that challenge, we have created a workflow that is an in-house developed workflow, and that's one of the best practices that we are using today. It's called Workflow for Adversary Verification and Evaluation. We call it WAVE. WAVE is basically a common language. It's a method of structuring information, right? So all of these teams can understand each other when they're talking about adversary behavior. So that breaks the silo, basically. And we are just hang tight. We will be going in detail on this framework in the later part of the presentation. And one more thing that I want to call out here is that when we talk about collaboration, sometimes it is important to use methodology like Agile, right? So we have adopted Agile as a methodology, and Agile is helping us to collaborate better and respond faster when there is a situation or a problem. All right, that was about the challenges. Let me, while I'm working on, I'm talking about the entire cybersecurity program, and before we dive in Wave, let me also talk about how this workflow is working in Target. So all these three teams, when I talk about cyber threat intelligence, detection engineering, CSIRT, how the information about an adversary behavior passes through from a narrative reporting. Narrative reporting is nothing but tons of information, right? And from the narrative reporting, how does a threat analyst pick up that relevant information, convert into uh, the information that is needed by a detection engineer, and then detection engineer write a rule to fire an alert on a glass for a CSIRT analyst. So just I'll go step by step. So threat analysts basically work on collecting the information from different sources. Like it can be Twitter has been a great tool for open source information today these days. Or you may have a tie-up with some of the threat intelligence agencies where they are feeding you intelligence. So threat analyst, if you have a threat analyst in your company, their job is to collect that intelligence, convert into a TTP. TTP is nothing but adversary behavior, and we are aware of it. TTP is basically is the adversary behavior. They collect the TTPs out of that narrative reporting and convert into an actionable intel. And this is the crux. If you are sending the entire information, the load of information to your detection engineering team, they will be confused on what to write detection on. That entire information may not be relevant. So their job, and this is where the wave, the framework that I talked about is going to come into picture. This is we'll talk about it, how wave is helping in structuring that information. And then once the actionable intel is produced, it is sent to the detection engineering team for content development. Now another point is that indicated while the threat analyst is actually working on the narrative reporting, they keep collecting those, and this is important. You should have an indicator database where you can see or update new indicators that you see in the wild. So they keep updating the indicator database with those indicator of compromises. And then it is again feeded to the detection engineering team for IOC vetting, IOC basically indicator of compromise, vetting, and deployment, development and deployment. And once and in this process, you need to understand one more thing is, and this has been, I have seen this challenge is, detection engineering team gets the information, and then they might be missing some pieces. Uh, you should have a connect back to the threat intelligence analyst, and you should have that process where the detection engineer can go back to the threat analyst and say, okay, I need more strategic or tactical information around this threat actor or a threat actor group or affiliate or this behavior. So you should have that connect back to your threat analyst team. Going back to the detection engineering, once the content is developed, it's fired alert on glass, right? For a CSIRT analyst to monitor, analyze, and contain. And this is where when I say intelligence-driven, detection-oriented incident response, you are focusing only on the intelligence that you are receiving from your intelligence. And now your intelligence team has to be they need to work a lot on collecting what is relevant for your organization. And we are going to take an example here as well. Um, the other thing that I want to talk about is in the same workflow is that CSIRT team should have a continuous feedback loop to the detection engineering team. It means if the CSIRT, and let's suppose the CSIRT analyst is working on a case, there can be two outcomes for it. They find something new. In this case, when I say feedback, they find something new which while doing analysis, and you should have that process in place where they can go back to the detection engineering team and say that I have found a new indicator. Can we have this updated in our database, right? And then you have, if something is you can call it a false positive. You say, okay, if a rule fire an alert and the CSIRT analyst finds it like it's a business as usual activity, this is valid. They can go back to the detection engineering team and say, this is valid. You can actually tune it. So you should have that. So this is important. This will reduce the overload on the dashboard for the CSAT analyst continuous, and this is continuous practice. Two more things here. One is threat hunting. Why have placed threat hunting in detection engineering CSAT? Because in Target, both of these teams focus on threat hunting. The detection engineers, they focus continuously, look in the environment, try to see the presence of adversary behavior. If they find an adversary behavior presence, they build detection on top of it, and if something which needs to be taken care immediately, they contact the CSIRT analyst to work on it, to contain that. And CSIRT team also continues to look in the environment to see the presence of a threat actor, adversary presence. The last thing on this slide is, and this is also very important, review the efficacy of the content. And what happens, your detection team continues to build rules, because the threat landscape is huge. But if you are not reviewing the efficacy of your content regularly, your systems will be overloaded with the rules, and your CSIRT team might be receiving which is not even relevant today. So your detection team needs to go back and say, okay, is this rule relevant today? Or is there a change of, or look at the trends. So for example, pick up any threat vector, right? And look at that, look at all the rules related to that and see that, okay, is it working or not working? So we in Target, we look at, we review the efficacy of the content regularly, which helps us reducing the load on the CSIRT analyst, which is not required basically. All right. And all of these I talked about, it is supported by Agile, which helps us to collaborate better. Again, I am just stressing on the Agile because it has helped us, and I'm sure that if you're using it, you have noticed this. So I will move on now. So in the same slide, and after this slide, we are going into a wave deep dive, basically. So let's take an example of the workflow that I talked about. So this is a tweet basically, and then this is a open source intelligence that a threat analyst receives. I'm just giving an example here. And this intelligence is about a quackboard. It's a malware that may be relevant to your organization. And then the same information is posted by like Trend Micro or any other open source intelligence, AT&T here, right? About the same malware or same adversary behavior. And once the analysts work on this open source intelligence, they pick out those pieces. So for example, we picked out of this piece here out of this entire all of this information that, okay, the quackbot uses a technique called process following, which is for BITER it will be like T1055 .012. That's the technique, right? And so the threat analyst picked that technique out of that narrative reporting and converted into structured intelligence. So now this piece is important because this is what goes to the detection engineering team. So they don't have to do a lot of work around collecting the intelligence because this is not their job. Their job is to write detection, so they can focus on detection. So this piece, what you see is the structural intelligence, and this goes to the detection engineering team to write rules, to write content on top of it. So you can see that the intelligence talked about explorer.exe, mobsync.exe, or IS2 explorer.exe, and the detection engineering team is creating a rule on top to match that situation. And then it fires an alert on glass for the CSIRT analyst to work on the alert. So far, I have talked about the overall program, right? Overall program, how the process flow works. And when I talked about Wave, I think this is a time we should go deep dive in Wave. So I will call my colleague Chandan Chandan works on Wave day in day out. His job is to build detection, uh, work with intelligence teams, work with CSIR teams, and he is going to share some interesting experience around using this framework. We are in the evaluation phase of this framework, and he's going to share some interesting things. And at the end of the towards the end, we have a good demonstration which we have built specifically for this masterclass using the open source infrastructure. So just hang tight. I'm gonna call Chandan. Chandan, over to you.
Yeah. Thanks, Bhupesh. You can hear me, right?
Yes. So, Bhupesh and Chandan, before we start and deep dive into the wave, there is one question regarding the workflow which you presented, Bhupesh. And the flow is definitely to go from intelligence and then setting up the detection rules and then feeding it to the IR team, right? So the question is regarding the automation part of it. So how much of the automation is possible, because we receive a lot of alerts and those intelligence feeds at a scale. So how much of intelligence automation is possible in this particular workflow?
So the automation. Can you?
So, is there any application of artificial intelligence to automate some of those workflows? So, you will create some of those sequences based on the intelligence that you receive. So, what level of automation will be possible to fast forward this process in the complex scenarios?
Yeah.
So, that's the question.
Vivek, can you just go on mute? There's a lot of background. Yeah, the automation is possible. Now, the automation, there is a possibility of automation. How do you collect information and then process that information, right? So, if you have different sources coming in, and you have information coming in from Twitter, you have information coming on different sources, right? If you can process that information at one place and see what is relevant for your company. So if you are, let's suppose, I'll give you an example of a threat actor. Chandan, correct me if I'm wrong. The TA551, right, is a threat actor. If you are tracking the threat actor, you can actually automate the behavior around it. So if you are collecting the information around TA551 from different sources, you can automate that behavior and give the information that is relevant for the threat actor TDP. Now that is one part about the intelligence team. Now from the intelligence to the detection team, now you have different tools available, right? So you talk about the incident management tool, right? Now your incident management tool can do a lot of things uh, if you are able to do automation on the incident management. What is, if you can connect those dots with your detection engineering, intelligence engineering, you can you through the incident management team, you can take a lot of actions, right? For example, if you have a threat actor, I'm just giving an example. You have a threat actor, you want to kill so there is, if we talk about EDR solutions today, there is a process where you can actually isolate a system by sitting on a screen, just by press of a button, right? That's the automation, right? You just click on, and you can actually, when you see a behavior, you can actually kill that. They will kill that activity. That's part of automation, right? So these once the point here is, if you understand the what are you looking for, the automation, the next point to automation starts. It can happen in your incident management process. It can happen in your how you collect intelligence. It can happen in your, I will another give you another example. How you look at your phishing emails. Let's suppose, I will give you a very classic example. You get a lot of emails. Now your job is, as a cybersecurity team, look at all phishing emails, evaluate them, right? And see that, okay, is it really a phishing email or not? Your, I have seen that CISO analysts sometimes look at those emails and say, no, this is not phishing. Or if you have built a process in your organization where we say, okay, if you tell tell your employees that if you see an email and you feel it's a suspicious email, you report it. Now the team the employees will start reporting it, but the lot of these emails will not have the actual phishing threat vector, right? I mean, they found it suspicious because they don't know about that email. Now that give a lot of work for the CSAT analyst. Now think about automation. If you have a process which can actually evaluate those emails at a point and collect that information which is actually relevant for phishing threat vector, it can go to the CSAT analyst to look at the real actual phishing uh, threat vector, right? So again, there is a lot of opportunities in when you look at threat vectors, understand threats, and these threat actors. There is a possibility of automation.
Right. I think Bhupesh has covered it very well. So other thing I just want to add in that is like, for example, Bhupesh talked about open source Intel, right? Even that Intel, right, coming on Twitter, so you can do API calls and bring it at one place, and you can easily figure it out. What are the various analysts who are talking about that? You touched upon artificial intelligence, right? So Bhupesh talking about the blogs and all. So even the work is going on, right, to use natural processing languages to read out those logs automatically and pick up the threat vectors, and those kind of things are also there. Again, indicators of compromise. So there are processes. So the moment you see the indicator of a compromise, you have to place it in a file or at a place. So automatically it will be taken it into the system, and it will be immediately tasked automatically. So there's a lot of opportunities out there. Yeah.
Over to you, Chandan. I think you can start with.
Okay, so I'm just going to share my screen. Just let me know if you guys are able to see that. Just a minute. I think I'm not able to get the screen of the PowerPoint presentation, so I've just shared the entire screen, I guess. Can you able to see that? Just let me know.
Yes.
Okay. Okay, let's continue from where Bhupesh has left. So I'm going to, so what I'm going to do is I'm going to uh, talk about the wave process which we follow. Then I'm going to talk about how wave help us in creating an actionable intelligence, and then how we can use that intelligence to fire an alert. So that we're going to see in the demonstration part. So on your screen right now you can see the wave. So before jumping or riding this particular wave, I just want to give you a small background. I think Bhupesh has also touched on those some of those points. So how the wave got evolved, or how the team created the wave process in our organization. In the recent past, the team was extensively working on the collection and analysis of ransomware attacks. So they were able to collect a lot of TTPs which are related to ransomware. They were able to collect a lot of their new and evolving techniques, their extortion methods, and why there is an uptick in the ransomware attacks in the overall landscape. They were able to collect a lot of information, but that was pointless if they were not able to use that all the information in an efficient and effective manner. So I think that's the problem Bhupesh was talking about and industry is facing. Team thought, okay, let's try to solve this particular issue. They thought, okay, we will go in a structured way. They tried mapping all the TTPs to the detection domain and whatever exists in detection over there. They try to use various models, existing models like MITRE ATT&CK or the kill chain or the diamond model. Somewhere they found those are working. They are too complex, and still there were some places where the information was falling into the gaps. So this led to the spark of some of the new ideas, which led to the evolution of the wave process. That's the background, and that's the problem. And basically, you can say that you can have a glimpse of the problem that we are trying to solve. So Wave stands for Workflow for Adversary Verification and Evaluation. So targeting created it. So basically, Wave helps in tracking the two parts on a single page. So first one is the techniques and procedures of threat entity and the resulting custom detection from those particular TTP. So once they are on the same page, you can get a clear picture or a holistic view of a threat actor, of the threat actor, and all the teams can get benefit out of it. So by now you understand what problem we are trying to solve. These are the immediate key benefit which we have provides. So the key benefits are like, it makes our intelligence more actionable. So which means that, as Bhupesh also has shown you in an example, the intelligence will come in a very crisp and in a scoped format, right? So that can be used by the detection team or the other security teams in the organization in as is manner, and they can create a detection out of it, or they can do a threat hunting out of it. So Wave helps us in speaking a common language. Because we have created a Wave by integrating different ingestions or different output methods of the various teams, so it speaks a common language, and it is very easy to flow the information between the teams. So Wave provide a standard format for information sharing. So when I'm going to explain, you will see some of the metrics, which is a very standardized format. Again, every team will be using that, and then this create a kind of a common culture. They can go back, feedback loops. Everyone will be knowing what exactly they are working on and what they are going to expect more in that terms, right? I've told about like it gives a holistic view, and then it also helps in tracking and analysis. So tracking and analysis is mostly related to figuring out the maturity of your detection, right? So mostly here, for the tracking purpose, you will see these things will be having the mostly the dates. For example, when was the last uh, particular TTPC in the wild, when they upgraded, so all those kind of things will be there, and this will help in the tracking the maturity of a particular threat entity or a threat actor. Um, so moving on, so what I'm going to do is I'm going to talk about. So you can see the terminologies over here which we use in the Wave process. These are some very similar, very simple words which you might have already heard of, like threat entity or prevalence level, attack flow, phases, all these kinds of things you might have already heard of. What I'm going to do is I'm going to explain these terminologies, and I will tell you like how they fit into the Wave process, and from there we can take it up, and you will be having a better understand how the overall Wave process work. So first, I'm going to talk about the threat entity. So a very simple term, you might already be knowing it. So this encompasses like various threat actors, right? Their affiliates, their groups, or generalized threats. So everything we just put it under one umbrella and we call it as a threat entity. So this help us in grouping and again providing a complete holistic view of that particular threat entity. Everything will get grouped under this. So I'll just take an example on the right hand side. The APT32 is a threat actor, and you can see its associate groups and its description. I've taken this from MITRE side. So you can see here the sea lotus or ocean lotus. These are all the associates of this particular group, right? So we are just going to use it as an umbrella in our whole framework, the threat entity. You will hear this word again and again. So next thing I'm going to talk about is the prevalence levels. So prevalence levels basically talks about the frequency of a particular TTP being used in an attack, right? So there can be a TTP which a threat actor can use again and again. So that helps us in understanding the prevalence level of that particular TTP. So for example, if there are 10 attacks by a threat entity, right, a particular TTP is used in 8 attacks out of 10. We will call it as that particular TTP is highly prevalent, right? So this helps us in taking some of the key decision, related to prioritization of our work, which particular TTP we should be focusing on, and we should be able to detect and guard against, right? So we can divide, or we can categorize prevalence level into 3 parts as per the Wave matrix. So highly prevalent, medium prevalent, and low prevalence. As I mentioned, TTP which are seen in majority of attacks by TTP, that they will be categorized under highly prevalent TTPs, which are seen in the majority of attacks. We categorize it under medium prevalence, and the TTPs which are rarely seen, right? they are categorized in the low prevalence. So you can make out easily from this particular thing that we have to focus on, right? So normally if you see some of the frameworks, they will group all the TTPs, right? But you don't know which one to focus on, which one to target. So in this case, if we know that these are low prevalent TTPs and they are rarely seen, we can just leave it just like that, and we should not waste a lot of effort in detecting of those kind of TTPs. So prevalence level helps us in prioritizing our work and all. So the wave matrix. So this is the heart of the wave process. This is where actually the intelligence team starts to share the intelligence. So why we call it as a wave matrix? Because it integrates the intel, the how intelligence team look at a particular TTP to verify its threat entity, with the detection team looking at the same TTP and evaluates uh, the detection coverage, right? So this integrated view helps in easy flow of information, easy production of information, and easy consumption of the information, right? So this framework can be used as an add-on or in conjunction with the other models like micro framework or diamond model. But essentially, one important thing which it calls out is which is different, that it can help in making the intelligence more actionable. So that's where it stands out. So we'll see that in a minute. So on the screen, what you're seeing is there are two sides to it. There's an intel side and there is a detection side, right? So the intelligence team basically sees the TTPs in a linear fashion, right? And they can categorize it as they are seeing on them, right? So you can see here, so the intelligence side is divided into the rows. So you can see there are various stages, which is intrusion, host activity, propagation, and end goals. So these we have taken or modeled from the kill chains only. So what we have done is we have combined some of its phases, which are the major stages, and we have stripped off whatever is not relevant from the detection and intelligence standpoint for this framework. So what intelligent team does is what they're going to do is they are going to categorize TTPs linearly into this particular matrix from the intelligence standpoint. So if I have to take the first row, you can see that there is an intrusion phase. So intrusion phase means like every threat entity or a threat actor, when they are going to attack, they are going to intrude into your network. They are going to do some sort of activity which with the help of which they are going to enter into your network. So all those activities or TTPs which will be collected in the intrusion path. Then the host activity. So in this all the activities which a threat actor do inside our network on a particular host, all those TTPs or activities are collected over here. So it doesn't mean that we can't add those TTPs which are doing some sort of communication to the external networks. Important over here is if that activities is happening at the host, we can we can put it or categorize in the host activities, right? So next you can see the propagation. So propagation basically is related to a lateral movement. So if there are any activities or if there's any TTP, right, which is trying to further infect into the network or move laterally, so those activities will come into the propagation phase of the attack. So you can see in the bottom of my screen that the propagation phase is cycling back to the host activity, then to again to propagation. So normally the threat actors tend to do this till the time they will find out a particular thing which they are after, an important piece of information or a data. So once they get that, then they move on to the last phase of their attack, which is the end goal. So all the activities which are related to their end goals will be categorized in the end goal stage of the attack. So end goal doesn't means that the threat entity will be completely out of your systems post this. It's that just marks the completion of one episode. They can still start the attack or the host activities later on as well. So now we'll see what's happening on the detection side. right? So detections, so this is an excellent representation like how detection team sees a particular TTP, and they will evaluate what kind of detection coverage they already have and where they can detect a new TTP in a which domain. So from a detection side, you can see there are columns. So you can see the columns external, ingress, internal, and egress. So they are going to use these. These you can consider as a domain boundaries. So they are going to categorize the TTPs from the from this standpoint. So for example, uh, uh, the uh, the stages are categorized into a network boundaries. A particular TTP when can cross this network boundary or it can stay in that network boundary. So this means that this give a good indication to the detection team where to detect upon them, right? So we'll start with the external. So external is basically mostly used by our intelligence teams. So remaining three will be used by the detection team. So external, in external domain, we will collect all those TTPs which are related to the activities which are external to our organization, which means that we can't see them in coming in our network at any given point in time. So this is related to the information which we can collect from the dark webs, right? So this is a unique to this framework, and this helps in giving the holistic view of the threat actor, how it starts and how then they enter, and they go after the things, and then they go out of the thing. So this is still important. I'm going to talk about some of the examples in the next slide, where you will see what kind of TTPs which will come into the this external stage or an external domain. So next I'm going to talk about the ingress. So same analogy as it is used by the network teams. All the activities which are happening while a particular data or information is coming into our network, right? Example, if I have to take the file download, right, or the emails coming in. So all this is the ingress traffic, and how we can detect that. So I will take some of the examples, like you can monitor this incoming traffic through various signatures like Yara signature, or you can use some rules on our exchange server to detect this incoming traffic, and that's the best tool to detect some of these TDPs. So next is internal. So you can see this wave graphic. This is exactly mapping to its columns, right? So now if a threat actor is coming into our internal network onto our host, so all the TTPs which are related to the host activities, they will be collected in this internal domain basically. So what I'm trying to say over here is, for example, if there is a process execution, right? So that will come in here. If there is a script execution, if there is a changes in the registry which is made by threat entity, so all those activities will get categorized here. And some of the SIM tools or EDR tools are, so these are our best friends. So we can detect all those kind of TTPs with those things. So last column is the egress column. So this is where mostly TTPs will come, uh, which depict all the activities which are going out of our network. So if I have to take example, so any connectivities to the C2 domains to download a second stage payload, or exfil of data. If a threat entity has reached its end goal, they are just trying to do the exfil of data. So all the TTPs will come in this particular category, and network logging or monitoring your C2 domain traffic are your best tools or to detect all these kind of things. These are some of the examples I'm giving. Obviously, there can be more, so it can help you to detect these kind of TTPs. So that's the overall matrix which is filled when the intelligence team look at the overall holistic information. So I'll just show you now the various examples. So here you can see some of the examples how this matrix is filled. So you can see on the right hand side, I was talking about the external domain. So all these TTPs which you can see here, right? You can't see them inside your network mostly, like social engineering, right? But the moment okay, this is the social engineering tactic which can be used, right? The holistic picture of the threat actor. You can use some sort of training mechanism in your organization to highlight those kind of things, and from there, it can be helpful, like to guard against them. So, but this overall helps us in giving the complete picture of it. And similarly, you can see the other TTPs like phishing, where they're getting fit. Here you can see in the egress there is a it's connecting to a C2 domain and downloading the stage 2 payload. So this is the overall matrix, how it looks like when it fills up, right? Another thing I want to highlight over here is you can see that there are different shades of gray over here, right? There are some darker, there are some lighter gray. So darker shades of gray depicts here is the TTP, which is highly prevalent, right? We talked about prevalence levels in the previous slide. So these are the TTPs which are highly prevalent, right? Which are commonly seen. So this gives us a generalized view. Okay, this particular TTP I have to guard against, I need to detect that, right? And the TTPs which are of low prevalence, right, we can think of like how much effort is required to detect them, and those kind of things. So those kind of decisions we can take here. So this was the example of overall wave matrix. So I'm moving on. I think I've covered everything over here. Okay. So wave process flow. So far we are just talking about it helps various teams, and it breaks the silos. So I'm just zooming in, so you can see on my screen the various teams that it helps, right? So what I want to talk about here is like wave was born basically to make the intelligence more actionable and to reduce the duplicate analytical work which different team does. Because prior to wave, intelligence team were ingesting the data, but that was not directly translating to the workflow of the various teams, right? They have to still do some sort of analytics on top of that. By adopting the wave, what it has done is it has created a common language for every team. So now and all the ingestions and outputs of various teams have been integrated or considered while creating this particular workflow. So the work which is done by our intelligence team can directly be used in many workflows of the various teams over here. For instance, right, I'm part of detection team, so intelligence team will fill up all the TTPs, right? So they can directly pass on that particular information to the detection team, which will be very crisp and clear, and detection team has to just pick up and create a detection on that. Normally, the detection team will not have to do any further, kind of a research on that. Uh, and apart from that, if there is anything missing out, right, so detection team can easily look back to the intelligence team and get more information. Similarly, same TTPs or same actionable intel can be passed on to our hunt team. So hunt team can basically do the broader scoping, and same TTPs can be passed on to the red team. Red team can use those same TTP and check the existing detection content, that is it working fine or not. Then both of these team can also give it back to the intelligence and detection team. We can create a new detection out of their recommendations, or we can fine tune our rules based on their recommendations, right? So wave ensures that there is an easy handoff of the information, a transparency, a feedback loop which is properly set up, and teams can work very easily. So one more point I just want to add over here. One of the more outcome of the wave process is the attack flows, which we are going to see in the next slide. But incident response team can get the benefit of the attack flow during the active attack or during the post-mortem phase, and then they can see what kind of they can refer back to the matrix and see what kind of threat entity they are dealing with. They can expect what would be its next step or where to focus on. Lastly, I want to talk about this. It's not that this wave process can only be used by the bigger SOC team. It can be used by the smaller teams as well. There can be a team where same practitioner is going to wear a hat of, let's say, threat intel analyst or a threat hunter. So what he has to do is he can collect the TTPs and then can properly document it as per wave process, and then he can use the same process flow, and he can use his hunting skills to hunt him down in the network and try to find out any evidence that if they are under some sort of attack. So that's the overall process flow, and how the teams can take help from each other and understand clearly and speaks the common language, right? So next, I was talking about attack flow. So next thing I'm going to talk about is the attack flow. So you can see here on the slide a typical attack flow of Maze affiliates. So attack flow essentially is a blueprint of an attack, of an actual attack. So how this is created. So once we create the matrix, so we can use its fields to model this particular attack, right? So what this is depicting is the next probable path, right, a particular adversary is going to take. So in this particular image, you will see the highly prevalent TLP wide TTP of Maze affiliates, right? So you can see, so I'll just go through from the beginning. So you can see here the attack starts with with the phishing email. So the phishing email will come into the network. They'll try to get initial foothold into the organization. They will try to install some sort of a beacon over here. So in this case, it's a Cobalt Strike beacon. Then they will move on to the next stage, which are the host activities. They will try to deploy a Mimikatz or a Bloodhound over here to scrape the credentials. So then they will just use those scraped credential and store it into a file, and then they can use a RDP connection to do a propagation to find out more host or the information which they are after. Once they find out the information or a data which they are after, they will move on to the right hand side to the next phase here. So they will deploy some more scripts. They will zip the data, all the data, and they will take out the data as part of their end goal through the FTP, through the use of PowerShell script to the FTP, right? And once they have data and they know that okay, that data can be used for extortions, so they will deploy more scripts which will deploy some text file which contain host related details, and those host names and all will be used to deliver the ransomware. And then a script can they'll be running a script which will kill all the important processes on the system, and ransomware and ransom notice displayed on the screen. So this is the overall attack flow. So this helps the teams like incident response team, like what is the next probable step a particular adversary can take, and then they can dig on that particular part. Another thing I want to point out here is that the tactics of the adversary will change, right? With time, threat actors will evolve. So maybe there will be a particular TDP which will get changed. So Wave helps because we are collecting all the TDPs in a particular matrix at any given point in time. You can filter out high prevalent TDPs, and you can again create up to date attack flow of that particular adversary. So that will Wave will clearly help in creating this particular attack flow. So now we'll see is from the detection standpoint. So from the detection, so my goal is to stop the adversary at the beginning. It should not cross the line. So this attack flow again will help us, to figure out where I have to add more detection. Uh, so for example, so first of all, I like in this particular rack I should be having a heavily monitored incoming data, right? If there are any phishing emails coming in, I should be able to detect that then and there and block the attack. But if somehow they were able to install the Cobalt like beacon because some other process, or they sneak in, I should have some way to detect them when they are going to scrape for the credentials over here. So I should have some sort of process when they are running a PowerShell script. I should have some sort of detection how they will zip the data or encrypt the data, right? So I should have the detection mechanism at the multiple layers to detect that particular attack. So remember, I'm talking about these are highly prevalent TTPs, right? So if I'm able to detect all these TTP at a multiple layers, the ability of a particular threat entity, right, to attack us will severely diminish if we are trying to figure out everything over here. Other thing, this particular attack flow tells the detection team clearly, right? These are like high priority, threat actors. They are most prevalent, and there we need to add on more security layers. So as I mentioned, again, the threat actors TTPs will change. For detection team, this will be changed, but it is virtually impossible, right? Even they change some of their tactics, they will hit something or other while trying to achieve their end goal. So in that way, we will break their attack flow, and we can detect them in our network, right?
So then, just a time
Yeah.
check. We are at 10:35.
All right. So I think I have to just talk about one more thing, and then maybe we can just directly jump into the demo. All right. So last thing, so timesheet. So this will store end-to-end data. So when I say end-to-end data, so these are taken from the wave matrix, which I've shown you. And this particular timesheet is for a particular threat actor. So there will be a lot of fields. So I can't, fit all the fields in here, but we can broadly divide it into three categories: the TTP fields, or sharing fields, or maturity fields. TTP fields will be containing all data related to a particular TTP, their description, their overall context, right? Sharing fields are basically those fields which can be used later for the purpose of further analysis. For example, in sharing field, you will see the priority levels, right? Or the TLP information of that particular TTP. Maturity fields I talked about earlier also, this will contain the dates, basically when the TTP was first seen, when that particular TTP upgraded itself, right? How much, when we created the first detection, how much detection, and when the detection was created, how much detection is there for that particular TTP. So those will contain in these particular field. This will help us in better tracking our maturity, and help in briefing, and feeling comfortable, like that we have a detection for that. So one of the outcome of this particular timesheet is this actionable intel. So even Rupesh has shown you. So this will be very crisp and clear and ready to use for the detection team. Prior to that, we have to go into a blog, and you will just see how much detection you can do. You can build 5 detection out of it, or 10 detection out of it. Here you will get the crystal clear information, right? This is what the expectation is, and we need to answer on 3 questions: that can I detect this particular thing, can I not, a reason for that, or can't I do now, and later on, like if I fulfill ABC requirements, and I can have a visibility, and I can detect on that, right? So just going through, so I have taken few columns, like I've seen in actionable intel, 11 to 15 columns normally are enough. Kind of give you complete view, like what exactly is expected out of a detection team. So here you can see which threat entity it is belong to. It's TF551. Then phases, basically it's a host activity. So this will give an idea to a detection engineer, where he has to think, like in which domain this can be detected. So he can just go into that domain and try to detect it. Then this is a TTP name. So this is a process following process injection. This will again uh, uh, help the detection engineer to understand, okay, I need to detect a process injection, right? So they can just think in that term and just go into that line. So then is the little bit of description, which will just set the overall context. Then the priority. So this is a medium priority, medium prevalence level. So based on that, we can prioritize it. So then it's a TLP white information. Then you will see some MITRE details as well. So this is to complement the complementary to the MITRE framework. If we are using the MITRE framework as well, then there are samples. These samples basically can be used to take out some of the strings and do some further analysis, right? And even you can run it in a sandbox, and you can yourself see, right, that is it doing a process injection or not. So then the observables. So these are basically sent by the intelligence team. So this is their observation, right? So they are saying, can we detect that? So this is again, pointing to a direction, that this is what we want to detect, and this is the external report, right? This is a blog from where this particular intelligence has been taken. So now this actionable intel will be directly transferred to the detection team, and they can detect that. So in the demo, we're going to use this one, and we'll try to detect that. Okay, so I'll move on in the interest of time. So before starting a demo, there's a small disclaimer. So whatever demo I have created, this is created for DSCI Masterclass. It does not contain any real data related to target corporation. This is just for educational and demonstration purpose, that how finally things are done in practically in the environment, right? So I've used mostly open source technologies to do that. Right. So before jumping into the practical things, I just want to share, give you the overview of the architecture which I'm using for today's class. This will help to understand when I'm in actual machines where I'm doing what basically. So this is just a flow. So on the left hand side, I'm going to start from the left hand side. So you can see there are some Windows machines. So what I've done is I've installed a sysmon and winlog beat on these particular machines as an endpoint agent, so which are going to send data directly to our Elasticsearch container over here. So I'm not using any sort of intermediate shipper after WinBeat for my convenience. So normally you will see some sort of log stash that will be mutating your data, or find or filtering out some duplicate stuff. So for this demo purpose, I'm just taking out data from a sysmon and I'm just writing it on WinBeat and just sending directly to the Elasticsearch. Another thing I'm using is the proxy server. Why I'm using proxy server? I just want to show you how we can block certain domains and then we can just generate an alert for that. So again, this is a manual process and this can be done in an automated fashion. So I'm just going to show you like how things happen. So in this case, this is a Linux server. So I'm using a beat service, file beat service over here, which will be passing the data to the logstash server. Why I'm using logstash over here is I'm using squid proxy. The logs are very raw. And I'm just using the logstash to filter out a couple of things which I need for this demonstration purpose, which is the IP address and the destination domain where it is reaching. So that's what I'm just doing it with the logstash over here, and then I'm just sending data directly to our Elasticsearch containers, right? So this basically is running Elasticsearch, right? So this will be our database. So all the data, whatever is coming from Windows or the proxy, will get stored in over here. So next piece of container, the Elast alert. This is very important to understand. So this is where we are going to write our detection. So I am going to show you how to write a particular rule in the Elast alert. So what Elast alerts essentially does is so once we write a rule in Elast alert, it will the alert engine will keep on running that rule and probing the Elasticsearch database. It will try to find out a match for that rule. If the moment it finds out a match, what we are going to do is we are going to insert again it in Elasticsearch itself, and we are going to show it in our Kibana dashboard, right? And I'm using one plugin as well, which will help us in connecting the Kibana to Elast alert. So through this plugin, we will be writing the rule. It's an interface where you can easily understand. Otherwise, if you don't want to use that plugin, you can just write a text file, and there is this. I'll show you a place where you can just put those YAML files, and your Elast alert engine can pick those files and keep running, and it can fire the alert. Another thing I'm using is Nginx. This is just working as a reverse proxy, no major use. I'm just using it as a reverse proxy over here. So overall, everything is inside our containers, apart from these Windows machines. So this is the outside. Why I'm using containers? Just for the convenience purpose, easy to set up and faster. And this whole environment, right, is just purely for a dev and demo purpose, right? And because in production, it will be very, very different, right? And also you need to consider some of the security concerns, right? Which will be there, like authentication, encryption of data. So because you will be storing some of the more confidential data into this, right? So with that, I think I will just stop the presentation and I'll just share my screen. I'll share you once again. Okay, can you see my VMware Fusion screen, Bhupesh?
No, not yet. What I see is
Yes.
the screen that you have
The
mentioned.
Fusion screen is visible.
Okay.
Oh, now it is. Now it
Yeah.
is. Yes.
All right. So what I've done is I've already started some of these services in interest of time. So this is the Windows box which I'm using, right? Which we will use to generate some alerts and we'll try to detect in the later part of this. Just let me just do a quick check on the things are working or not. Just a second. So let's open up Kibana. and see if it's connecting. And I will also like to open up another shell. Okay, let's see. Here. All right. So okay, Bana is working, and let's see. Uh,
And then we can skip the configuration explanation part and rather jump into the rules creation.
all right, sorry.
We have just
Okay,
15 minutes left.
okay, got it. All right. So I'll just focus on some of the key things which you need to know over here. So these are the containers, which are running over here, and you can see here the various index which I'm going to use. So WinLog, basically, I'm going to use it for the purpose of logs which are coming from our Windows machine. Squid index, I'm going to use this particular index for the logs which are coming from our Squid proxy. And the important one is this elast alert. So what I'm going to show over here is, so this will contain all the rules right now which are currently running inside the elast alert. So you can see here from these bars there are two rules which are running, right? I want to show you these rules. So these just look like this. So right now what this is depicting is these are just running, they're not finding any match. So you can see here the hits are 0. So, but essentially, this is showing that our Elast Alert engine is running, and it is running these two rules. And if there is a match, they will definitely go into alert. That's what it is showing. I'm going to open up a plugin to write the rules, right? So this is the plugin. So here we will just see these particular rules and write the rules. Another thing which I'm going to open is a dashboard where we can have these particular rules fire the alerts. So this is the dashboard. Right, load. Okay, so in this dashboard you can see this is the rules which are running. If there is any alert, they will come here and the details will be shown up here, right? So this is our basic plugin where we are going to create a rules. So let's talk about the intelligence which we have received. So this is the piece of intelligence which we were talking about. Rupesh has also shown you in the length, right? Quackbot will use a process following in order to inject itself into Explorer exe. If unsuccessful, Quackbot will attempt to inject itself into mobsync exe or iExplorer exe, right? I told you I'm using the sysmon. So sysmon will load all these kind of process injection in event ID 8. So we are going to use that event ID 8 to create some sort of rule, and let's see if it can detect it. So let me click on create rule. All right. So I've copied. I'll copy paste it in interest of time. So I think this is the rule. All right. Let's just see. Right. So this is the rule name. So demo.dsci quackbot.process injection for Explorer. So just put the rule name over there. So type is a frequency, which means in a given time frame, how many numbers of events should be there so that it should fire an alert. So I'm just saying 1 minute just for a demo purpose, and number of, if there is a one event, it should just fire alert. So normally best practice will just put it up to a 60 minutes, or depending upon case to case, we can take that. And the next thing is the filter query. So this is the normal, Elasticsearch query. Most of the Elasticsearch queries can fit in. You can use terms, you can do filters, you can use range. So I'm just using a query string over here. So it's just filtering out, winlog challenge is equal to sysmon, Windows event ID 8, and the target images explorer.exe or mobsync.exe or iexplorer.exe. So that's what I'm trying to filter it out. So Windows Event ID 8 will have two things, a source image and a target image, right? So the intelligence which we have got, nowhere it is mentioned what was the source image, right? That can be anything, 1, 2, 3, 4, or something random numbers and all. But we know, okay, this is a target image, and we can just try to filter it out and see how much, if there are any false positive or not. If there are some false positive, we can manage it to fine tuning and all. If there's a lot, then maybe we need to figure out some other, take another idea to do that, right? So I'm just going to save it. Just let me see if it is complete. Okay. So what I'm going to do is I'm just sending it onto the screen. You can use a Slack, email, or Jira to send this particular information. So right now we will be just ingesting it back into the Elasticsearch and we'll see it in Kibana. So I think it's complete. I'm going to save it, right? So now what we should see is this rule will start running and the count should go to 3. It will take at least a minute. In the meantime, I will just create one more rule which is related to our proxy and detecting a C2 domain. Right, so I'll just take that. Right. So something similar query. So what I'm whenever my squid proxy is going to block a website which is written in the block series, it will spit out a message of a TCP denied. I'm just filtering it out. Even you can you can just mention all the domains which you want to block or you want to alert on. That also can be done. Then what I'm doing here is include source IP port. So this is what it will include in the alert. If you don't do include, which I have not done in my previous rule, you will see it will just throw out the entire data. Just let me check if it's complete. Okay, just put a name. All right. I think we're ready. All right. Save. Okay, so now we have 4 rules. By the time they will start running in here, what I'm going to do is I'm just going to give you the existing rule. So there is a rule which says Microsoft Office run DLL32 exe. So if you go through that blog which Bhupesh was showing, you can just find it online. Qbot and AT&T Labs, you will get that blog. In that they mentioned that you should also monitor MS Office, Excel, or PowerPoint running run DLL32.exe. It's a sign of it's a TTP of many threat actors. They use it. So it's a good practice to monitor that. Then show you this rule. So I'm just simply using the sysmon event ID 1, right? And I'm just saying if a parent process is Excel and the child process is running DLL32.exe, you have to just fire it out, right? Same thing, I'm just including some of the stuff, and then it's a debug. It's going to Elasticsearch. And similar is this one rule, which says Microsoft running a PowerShell. So Excel should never be running a PowerShell, right? In a normal circumstance, there can be some exception, but normally, it is not seen. But if this is a widespread TTP which is used by many threat actors, so you can see here a parent process is Excel and the child process is PowerShell.exe, so it should just fire alert. So these are the existing rules. So cancel it. Let's see. Let's refresh it out. So now you can clearly see that already 3 rules have started running. So we have already one alert as well. This is because I think because of my previous testing, but we'll do it again. So I will just put it in the automatic mode. 20 seconds are enough. Okay, so it will automatically keep on refreshing. Let's apply. All right, so now you can see like 4 rules are running in, right? So we have created 4 rules over here, and you can clearly see that 4 rules are running in. And there are some alerts, so which are just because of the previous testing. So we will be just doing now. So this is our Windows machine. So let me just log in. Right. So if there's any attack, so the first thing which is coming out there is so okay, this is the Intel part. All right. So the phishing email, right, will come in, and the threat actor will basically try to lure or try to pursue you to fall for this particular email, open up this particular macro enabled Excel file, and this is how the normally attack starts. So what I have, so this is not an actual keyboard, so I've just created a simple injection kind of a stuff which will be injecting into the explorer.exe when we are going to run the macro, and in turn it should just display some alerts over there. So this is the Excel file which a keyboard or a threat actor would have sent. So user is seeing it and okay, he's saying like it looks very legitimate. It is asking to decrypt it, or by enabling the macro, the movement. It's going to enable the content over here. So there will be some hidden formula which will work, and which can trigger the scripts in the backend. But here, for everybody's reference, I'm just running it in a foreground mode, so you can clearly see here. So I'm just trying to inject explorer.exe. It's giving that particular message, and behind the screen it's injecting explorer.exe and running other commands as well. So the injection is complete, and let's see if we get the alert or not. So it will take time. In the meantime, maybe a minute or so, I'll just show you the block list for the proxy. So you can see here. Nothing else you want to see. The data is coming in. Okay, so in the meantime, so I just want to explain you how we can block a particular C2 domain. So I've just created a block list. So if you just refer to the the blog which Bhupesh was talking about, so there was one C2 domain which is used by the Qbot. So I've just added into the block list. This can be done in an automated fashion. So once this in a block list, if there is any machine which is trying to go to this particular website, so we have already created a rule. It will block it. It will not allow that particular machine to connect to that C2 domain, and then it is going to alert for that. Right, so yeah, we can now see the alerts which happened because of our previous activities. So you can see there are 3 alerts which have come in, which were from the existing. So Quackbot, what simulated Quackbot has used MS Office to run DLL32. So if I have to just go in the details, you can see here, right, the parent process. So this is the parent image excel.exe, and you can see the image is run DLL32exe, right? So it has hit one of our rule. Then this you can clearly understand, right? We were using the MS Office, and then there was a PowerShell script which run in the foreground. So here also there's no need. So normally in the environment that Excel is running the PowerShell. So very good thing to monitor. So you can clearly see here, like Excel exe is running a PowerShell script. So last rule which we have written related to this one was a process injection. So here you can see this is the event code 8 which we tried, and here you can see the executable is evil.exe, which injected a target process ID which is a explorer.exe. So in this fashion, the can be written, and you can fire the alert from here on. CISA can take on and they can investigate this. So last piece is related to the block list. So you can see. I'm just trying to open this. All right. So this is the domain. I'm just showing you now. Just trying to access that here itself. Right. You can see that proxy server will refuse it. So even if the QAC bot is going to run some sort of exe or something and try to connect to this particular domain, the proxy server will refuse the connection, and you will see a particular alert coming onto the screen in a minute. So the cycle of the last alert is like 1 minute. So at least it will take 1 minute to drop the Elasticsearch and bring up the alert. So that's it. Like we'll see, and maybe Bish, you can also take over from here, or that's the presentation part.
Yeah.
Maybe we are happy to answer any of the questions. And in the meantime, I'll just we'll see the alert.
Over to you, Vivek. We are ended the end of our
Yeah, I
session.
think very insightful demonstration, Chandan. Now I think we got insights over the wave flow, right? That you presented. I think the examples and demonstration really align with that. Bhupesh and Chandan, we have a couple of questions with respect to the wave framework that you just now presented. So people wanted to know that how do we measure the continuous improvements and effects of the framework and best practices that you just presented. So how do you measure that continuous improvement and effects at overall layer?
Yes, so very interesting question, Vivek. So as I talked about the content, you need to continuously evaluate your metrics, right? So when it comes to the framework, you need to understand TTP coverage. And when you talk about TTP coverage, that gives you an idea about how your best practice is working or not. So let's suppose if you pick up one TTP and you follow that attack flow, you know that how many rules you have written to kind of cover that TTP. So that is how you ensure the effectiveness of that standard or a framework. So you need to, as I said, the answer is TTP coverage, right? You need to look at
Yeah.
TTP coverage.
Yeah, right. Yeah. So there is a one follow-up question also. Maybe Chandan, you can take because it is regarding the detection, right? So was it difficult for you to adopt, or maybe any organization to adopt Wave framework if they are having existing ongoing SOC operations, and now if they think about adopting this Wave framework? So is it difficult for them, or how easy for them to incorporate that Wave framework as part of their security operations center? And there is another question that they ask, how this framework is different from the other intelligence frameworks, other threat intelligence frameworks. So these are the two questions regarding the Wave framework.
Yeah. So I'll answer your first part of the question first. How was it difficult to adopt, right? So I think every change, when it starts, right, it is people just resist that, right? They are in a comfort zone the way they are working and all, right? So when we started it, so the idea, the problem we were trying to solve was right, to create actionable intel, to the eliminate the duplication work and ease the flow of information and all. So once we adopted it, or once we started working on it, the way earlier work used to come to us and the way work now come to us, post adoption of there's a lot of difference, right? So we are getting now well scoped, crisp intelligence, which is very easy to work upon. So once we started working on it, we find it from detection point. I can tell, right, it was very easy to adopt that. It is reflecting in our productivity as well. People are doing more work. They are able to complete more stories. So initially, there were challenges to convince people and all, but now I think once they start realizing the advantages and benefits, right? So I think it become much easier in the later stages. And what was the other question?
Yeah, second question is more regarding to the how this Wave framework is different from other
Yeah.
intelligence.
So as I pointed out at kind of multiple places, right? So one advantage is, right, you will be getting straight away actionable intel, right? So that's how it is different. It is it can be adopted by all the teams, right? Because it has been created by taking the inputs or their ingestion or output methods of the various teams, right? So that's a clear win over there. Then I pointed out at one point that we are also tracking the external domain. So that's clearly standouts, and we will get a holistic view of the threat vector. So these are some of the key differences I can point out.
Oh, okay. So I think there are a lot of questions, and we are very got
Vivek,
Vivek,
I'm
we
not able to
can't
hear
hear
you.
you. Vivek, we can't hear you.
Can you hear me?
Yep, I
Yeah.
can.
Yeah. Okay. So I think there are many questions audience is asking, and but I'll take one more question. So, is there any available marketplace image for any of the cloud vendor? So you mentioned all those flow and examples. Is there any available image so that they can use it on any of the cloud vendor?
Well, can you go to mute, Vivek?
Yeah.
Like what? Um, I'm sorry, I would not be able to give details about any vendors here because I'm not aware as right now. So if you have any questions related to the vendors, you can get in touch with the with our communication team, and they will get back to you.
I think that really nice and insightful session, Bhupesh and Chandan. I think people have definitely learned about the wave framework which you have presented, and some of the examples and demonstration which Chandan demonstrated. I think those are really helpful in terms of how to leverage the intelligence to identify some of the malicious events, and those examples on a Kibana and setting up the rules was really helpful. I learned myself from those examples, and I think audience also might have got good learning from those examples and the framework flow. So thank you so much both of you for taking us through the framework and those examples and demonstration. I really thank our audience also for being very patient and asking questions and being interactive during the workshop. So thank you so much, everyone. So we are signing off from the workshop. But if you have any questions pertaining to any of the framework flow or any of the following questions, you can get in touch with the Bhupesh and Chandan. So they'll be able to help you with any of the additional questions.
Yeah.
Thank you so much, everyone.
And audience, just one last thing, Vivek, thanks everyone for joining in. If you want to get connected, you can find us on LinkedIn and you can get connected. And we will be able to answer any questions that you may have. Thank you.
Thank you.
So we are starting our other panel discussions in some time. Please stay tuned on the platform. Thank you so much, everyone.